So fly and fly.
My name is Brooks Agnew. This is X Squared Radio with the Potential of All Potentialities channel on Sci-Spy TV. This is the Inner Earth Expedition Part 2, the seismic evidence. One of the things we had to do when considering whether Earth's or planets form as hollow spheres is to try to collect as much data as we could that's already out there to support the hypothesis that planets might form as hollow spheres. And as it turns out, there is some existing data out there. There's some new data, and we want to consider that here in this very short presentation. First is that in the ordinary textbooks that one might pick up on planetary core geology, this is how seismic data is collected. We see the earthquake pulse at the top of this diagram. Let's say in Malaysia or Japan or Chile, there might be some strong earthquake on one side of the planet. When that earthquake occurs, the vibrations go down through the sphere of the Earth and they appear at other seismic listening stations around the planet. In doing this, we collect this information based on the time that it takes for it to travel through the planet. We call these waves pressure waves or shear waves, and as we collect them, we kind of get a sort of CAT scan of the Earth. Well, as we all know, the old theory of planetary core geology is that we live on this molten ball in space, and somehow we exist on these nice, cool tectonic plates on the outside, like cornflakes floating in a bowl of milk. All that sounds wonderful. We've accepted that for hundreds of years as the way all planets form. We make exceptions for the magnetosphere around the Earth. We're going to cover that in the section 3 of this presentation. But for now, let's just talk about the seismic data. In order to make that data fit the current model that I just described to you, we have to create these kind of shadow zones because these vibrations do end up at listening stations and we don't really know how they arrive there. Another picture looks something like this. You can see the pulse happening there at the top of the diagram and the vibrations going all the way through the planet and ending up at different listening stations. The problem with this model is kind of a religiosity of science, I guess, where we have an idea what our planet is formed like. Many PhDs and many planetary physicists have given their ideas on how planets form, and we can't really refute that old high priesthood of science. And so what we do is we make the new data fit the old theory. And that's exactly what you see here in these textbook diagrams. What has been done is we have reversed that way of thinking. In other words, we've used the same exact data, and what we've done is we've done it in reverse. Instead of picking up the data from the point of the earthquake, we pick up the data from where it appears at the other end. And then we follow the data back to the point of the quake. When we do this mathematically, this is what the model looks like. As you can see, there are no shadow zones in this model. This is the new planetary core geology. You can still see the point of earthquake at the top, but now you see a nice organized way that the vibrations go through the planet if you consider that the core or the center area of the planet is actually void. It's actually got a space with no mass in it other than something that won't transmit vibrations like an earthquake. It goes back to an idea, a hypothesis that maybe planets expand when they form out of these large accretion disks, or whether they form electronically or electrically out in the universe. They form as very fast spinning dense pieces of matter. And as they spin very, very fast, sometimes they become unstable and they explode. and they go off into asteroid belts or free-floating chunks in space, which we do see a lot of that. Or sometimes they become lopsided and they spin off a piece of themselves, and now we have a moon. We already see an evidence of that in our own solar system with Venus and Mercury. Mercury is large enough that it formed its own orbit around the sun, but this is what we speculate may have happened anciently. But sometimes we kind of hit this Goldilocks zone where instead of the planet becoming unstable and exploding or lopsided and spinning off a piece of itself, it just simply expands and cools, expands and cools. And so this idea of expanding Earth hypothesis has been proposed. Over a period of about 4 billion years, the electrically formed planet spins and cools, and the crust then begins to separate from its center, and you end up with a hollow core. I'll explain what might be in the middle of that in a subsequent presentation. But let's just talk about expanding Earth. It doesn't take much of a observation to see that all of the tectonic plates that we see above the ocean or just below the ocean level on the Earth once fit together very neatly. As you can see in the bottom image here, all of the landmass on Earth all fits together. Australia, Antarctica, North America, South America, Africa, everything fits together nice and neat. As the planet expands, sort of like a balloon inflating, you can see the tectonic plates begin to separate, and they separate nicely into what we observe right now as the continents on this planet. Of course, as a scientist, we have to ask the question, if that's true, then there has to be evidence to support that there's not only an outer crust, but there must be an inner crust. And if the crust is as thick as we think it is, based on the mass of this Earth, based on the orbit around the sun, the distance from the sun, and the amount of time it takes us to go around the sun, then we must have a crust somewhere around 900 miles thick. And there's a tremendous amount of mass in that crust. And that amount of mass must have its own gravitational attraction, which means there must be some kind of formation, some kind of activity on the inside of the crust, gravitationally speaking, as there is on the outside of the crust. And that is the Harvard model. This is the Harvard University proposal, that this might be what planet Earth really looks like. That we have this troposphere on the outside, which we enjoy and fly around in and can exist on the surface of, a thick and continuously undulating crust of 900 miles thick or so, and then a gap, and then an inner core spinning at a different, we believe, a higher velocity than the crust based on conservation of momentum. That makes a lot of sense. But if that was the case, I have to take this a step further and ask the question, there must be some evidence of some activity on the inside of this crust, gravitationally speaking. And lo and behold, Dr. Y. Sessions with Washington University commissioned his graduate students to go back through 600,000 of those seismograms. I showed you just one of them, and put them into a computer model to see if we could determine if there's an inner morphology. And this is what he quoted. We concluded, after 600,000 seismograms, that deep in the Earth's mantle, there is revealed the existence of an underground water reservoir, at least the volume of the Arctic Ocean. That's true. That is real, scientific, repeatable evidence, data, that shows that there is another ocean on the inside of the crust, at least as big as the Atlantic Ocean. How they determined that is they could sense the waves crashing on the shore on the inside of the planet. This is very, very compelling data. It presents an image of the Earth that may look something like this. This is one of the reasons why we decided to commission the greatest geological discovery in the history of the world, an expedition to the North Pole region to see if the crust is actually thin enough that we can determine an opening between the two oceans. It may not go all the way through like a hole, but it may be an opening in the crust where the two oceans blend. We intend to try to take an expedition to this area to see for ourselves. This is a short video for the Inner Earth expedition. Next time, we're going to do part 3, which is the actual sea-based evidence to support the Hollow Earth hypothesis. My name is Brooks Agnew. This is X Squared Radio on the Potential of All Potentialities channel of Sci-Spy TV. Thanks for being with us tonight.